Welcome to the world of data structures. Our today's topic is binary tree traversal algorithms. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today we first going to learn about the basic terminologies which we are going to use in our traversal algorithms. Then the very first algorithm is for pre-order, then for in-order, and the last one is for post-order traversal. Fine. So let's begin with the first basic terminologies used in algorithms. So here it is. First, see, this is your binary tree, okay, where 85 is your root node and the rest of the terms are on the tree. Like 78 is there, 65 is there. On the right side of the 85 we have 45, 56 and 23. Students, this is not a binary search tree, this is normal binary tree. Fine. Okay, so please don't think, sir, here smaller things are not left and greater things are not right, but because this is a binary tree, it is not a binary search tree. Fine. So here we are going to assign one pointer that is known as T. Okay, we know that the linked list starts from the first pointer. In W linked list we have left pointer and right pointer. In stack we have top pointer. In queue we have front and rear. So just imagine a situation where we have a T pointer which is always used to point root node of a tree. These students, here remember that any operation on tree is begin from the root node. That's why I am going to assign a T pointer on node 85. Okay, so here T is a pointer which is pointing to node 85. Now tell me, if root node 85 is known as T, then the left link of 85 is known as LPTR, fine, and the right link of 85 is known as RPTR, fine. Now just imagine the situation, if this is LPTR and this is RPTR, then can you tell me that what we called a node 78? If students, the root node name is T, that means if I am assigning a pointer T to the root node, then what is the name of 78? What is the name of 78? LPTR of T. LPTR of T. Okay. And what is the name for 45? It is RPTR of T. So students, here three terminologies are there. First, T pointer is used to point a root node, okay, where we are going to start the traversal. Then LPTR of T, that shows the left pointer of T, and RPTR of T shows right pointer of T. Fine. So let's begin with the next algorithm. So our very first algorithm is recursive pre-order traversal algorithms. See, if you remember the traversal algorithms, then we have three basic traversal algorithms. The first one we have pre-order, second we have in-order, and third we have post-order. So what is the difference between all of them? The way of traversing, the way of visiting the nodes, the way how can we access the nodes, that's different. As this is our binary tree, then we have only two possibilities, either go on the left side or right side. So according to the manner of traversal, we are dividing our traversal algorithms into three parts, and the very first algorithm is pre-order traversal, where we need to first visit the node, then go on the left side and then go on the right side. So here I'm just trying to remember you that pre-order means VL and R, that means visit, left and right. Fine. These students, these all algorithms are recursive algorithms. Okay. Okay, that means function calling itself. So here today I'm going to show you that how the recursion works for such type of algorithms. Okay, first let's understand the algorithm. So here the algorithm name is procedure R preorder of T. Okay, the question coming in your mind that, sir, why we need only one argument? Because we just need to access the first position of the root node. Root node starts from the T because T is a pointer which is pointing to the root node. That's why only one argument is needed, that is T. And students, here this is a recursion, we are not going to return anything. That's why such type of algorithms are procedures, not functions. Okay. So here the first is, see, V, L and R. So just focus on your methodologies or just focus on your examples that you have already done in pre-order, preorder and post-over traversal methods. So students, here we have V. V stands for visit. V stands for visit. So first you need to do is, first you need to just visit the root node. Okay, that means just process the root node. So here it is. If T is not equal to null, okay, why I'm just writing that T is not equal to null? Students, because T is pointer which is pointing to the root node. Suppose if T is pointing to null, that means there is no tree over there, or we can say tree does not exist. See, if linked list does not exist, then the first pointer pointing to null. If stack does not exist, then top pointer is pointing to null. If queue does not exist, then front and rear both pointer are pointing to null. Same like that, students, if my tree does not exist, then my T pointer is pointing to null. Okay, so here the first we have, if T is not equal to null, that means if tree is there, if tree is there. So to visit node, we just need to write like this, write data of T. Data of T, that means info field. Okay, here we have 85, so you just write down the 85. That means we have already visited the node, because what we write, we just write data of T. Okay, now else just to write empty tree. If your tree is equal to null, then you can easily write like this, else empty tree. Now after performing the visit operation, what we need to do is, we just need to go on the left side. So step number two is students, here it is, step number 2, that is process left node. Okay, now tell me students, if your tree, if a node, this node does not contain any left child, just imagine a situation, if this node does not contain any left child, then the LPTR, that means left pointer of that node, should point to null. So as you have already checked for the tree, here you need to check for the left pointer also, that if my LPTR of T is pointing to null, that means there is no node on the left side, you can move directly to the next step. But it's not like that. If your LPTR of T is not equal to null, that means if your left node is there or left child is exist, then what to do? Then you just need to call R preorder of LPTR of T. Here I am just calling the function again for LPTR of T. So what happens over there? This is a function recursion. This is the function recursion. See, first I am accessing, calling the for the root node. Okay. After writing the data, I am just move towards the left side. If in any situation, if my left child is exits, then I need to call this function again for this particular child. That's why I can write that call R preorder of LPTR of T. Students, here R preorder, where R stands for recursive preorder algorithm. Fine. R stands for recursive preorder, that means preorder algorithm. Okay. So here you need to apply that R preorder of LPTR of T on the left child of T. Okay. And then move towards the right side. Okay. First visit, then left, then right. So here it is, step number 3. It is known as process right node. Same as above, if rptr of t is not equal to null, then just call r preorder of rptr of t. Fine. So it is same as the previous one, only the thing is different that the value, the parameter we are passing into the function, that is r preorder of rptr of t. So that's it. Only 3 steps are there in this algorithm. Okay, why only 3 steps? Because this is recursive algorithm. Okay, in recursion the function calling itself. So what we are doing, we first call the function for the root node, then for the left node, then for the right node, or we can say visit left and right. In such situation we can apply our pre-order algorithm. That's it for the algorithm. So what to do next? Let's traverse this algorithm with our example. Today I'm going to show you how the recursion works, or how the recursive algorithm works for pre-order traversal. So here it is. This is my tree. This is my pre. Our same example as previous one. 85 is our root node, then 78 is the left of the 85, 45 is on the right of the 85, then on the 78 left side we have 65. On the left of the 45 students we have 56, and on the right of the 45 we have 23. Okay, so this is our binary tree. Now what we need to do is we just need to apply our preorder algorithm, or we can say our recursive preorder algorithm over here. Okay, so how to do it? First I'm just going to write down the basic steps of the algorithm over here, so you can read it very carefully. Step number 1 is check whether the node trees exist or not. If trees exist, then write the data. Step number 2 is go towards the left side and apply the function. Step number 3 is go towards the right side and apply the function. Okay, so these only 3 steps are there. As only 3 steps are there, I am going to execute each and every steps. I am going to trace this algorithm for each and every node. Let's begin. Very first we have students, in the initial stage t is pointing to the 85, so 78 becomes its LPTR and 45 becomes its RPTR. Okay, so let's begin. First I am calling the function. See here, if you can see this box, so this box is for the function calling. I'm going to use this box for function calling. Okay, why? You can easily get the idea of while I'm solving this answer. Okay, so let's begin. First we have call this function for 85. Usually what we are doing, we are going to call this function for 85. So call this function r preorder for 85 only. So at this point my t is pointing to 85, okay, so let's begin the step number 1, 2 and 3. Only 3 steps are there. Okay, so let's trace the algorithm for a node 85, and now here we have step number 1. Students, tell me, step number 1 becomes true because t is not equal to null, so it becomes true. Okay, that means you need to write data of 85. See here, while I am highlighting such colors, that means I am just at the position of 85. Okay, now after reaching the step number 1, what I need to do is I just need to write down the data if my step number 1 is true. Okay, so I'm just going to write down the data. Here it is. So I'm just visit 85. So here I'm just visiting 85 students. Then on the at this position I'm just writing the answer also. See, answer first we have 85. Okay, so in the answer line I am going to write down my visited nodes. Okay, or the occurrence of my visited nodes, or the pre-order traversal. This is my answer for pre-order traversals. Fine. So whenever I am just going to visit the nodes, after visiting it, I am just writing over here. Fine. Okay. So here 85 is already visited. So what to do? Step number 2. After completing step number 1 for 85, we move towards the step number 2. So here students, the step number 2 is LPTR of 85 is null or not? No, it's not null. There is a node over there for 85. So what you need to do is you just need to call function again for 78. So here it is, function calling for 78. See, I'm just showing you something because you will get the idea about the recursion. So whenever I'm going towards the step number 2, my function is again going to call, and this box represents function calling for 78. Okay, so what you are doing over here? See, at the bottom of that we have call for 85. Above call for 85. Above it we have call for 78. This is stack. If you remember the application of stack, we are going to apply the stack on recursion, or we can say recursion uses stack. So here it is. Fine. Okay. So this inner bracket or inner box shows the another function call for 78. This inner bracket again is known as for the function calling for node 78. Fine. So let's go further for the next step. Step 1 for 78. Okay. So here the step number 1 again for 78. So here it is. Step number 1 is becomes true because node is also there. So you just need to write down the data. So here I am just writing the 78 in my answer. Okay. And then let's move towards the step number 2. So here the step number 2 is true again because there is a node after visiting 78. I move towards the 65 because there is a node on the left of 78. Fine. So what we need to do is, students, here I'm just going to again write down the 65. Here I'm going to call function for 65 again. So here it is, our preorder for 65. See this another box, call for 65. This box represents call for 65. Okay, so step number 1 is becomes true. Okay, my T pointer is now moved towards the 65. Okay, so step number 1 it becomes true. Step number 2, that means after becoming true, step number 1, I need to write down the answer. I need to visit 65. I write down the answer in my answer bucket and then move forward to the step number 2. So here it is, step number 2. See, step number 2 is LPTR of t is not equal to null. So it becomes false. So here there is no node on the left of 65. That means step number 2 becomes false. So you can directly switch towards the step number 3 for 65. So for 65 I'm going to write down the step number 3. Oh, step number 3 is again false because there is no right node for 65. That means here all steps are completed for 65. Step number 1 to check whether the node exists or not. Step number 2, just write down for the left subtree, and step number 3 for write down for the right subtree. All 3 steps are successfully completed for node 65. That means this function call is completed, so it goes out from the stack. See, it goes out from the stack. Okay, see, before this we have all steps done for 65. As all steps already done for 65, it means this function call is successfully completed. So your control from the calling function 65 is get back to the 78. See, here we have just completed only 2 steps. Step number 1 and step number 2. We still need to complete step number 3. So here it is. Your control get back to the 78. T is pointing to 78 now, and you are going to write down the step number 3, which is RPTR of t. That becomes false again because there is no node on the right side of the 78. That's why all steps for 78 is completed successfully. Okay, so all steps are done for 78. Now what to do? Okay, so this function call is completed for 78. I'm just removing this session, just removing this function calling and get back to the control function calling control is get back to the 85. So here t pointers get back to the 85, function calling control is get back to the 85. Here we have just completed only 2 steps. There are step number 1, step number 2. Now let's move towards the step number 3. It is written over there that check right pointer of t. Now check right pointer of t. Is right pointer of t exist? Yes, we have 45 with us. So now t is going to call for 45. So now the another RPTR of t. See, preorder for RPTR of t. That means here t is pointing on the 85. Now t is pointing at 45, and the function is going to call for 45. So here it is the function calling for 45. This is a function call block for 45. Okay, Fine. So here the step number 1 is true. I'm going to write down the data 45 over there. Then step number 2 is true again. So what I need to do is I just need to move forward. I just need to move forward to the left side of 45. Students, here we have call 56. So another function calling is there for node 56. So I'm just calling the function 56. Okay. So here it is. From 45 I move forward to the 56. T is pointing at 56. Now step number 1. Okay, write down the data for 56. I'm just visiting the 56. And then step number 2. That is check the left pointer or move towards the left side of 56. Do we have anything? No. That will be step number 2 becomes false. Now step number 3, that is on the right side of the 56. Students, do we have anything on the right side of the 56? No again. That means move forward to the next step. Is there any step left for 56? Step number 1 is completed, 2 is completed, 3 is completed. That means function call is finished for 56. So here for 56 function call is completed. That's why my control is get back towards the parent node. Here all steps are completed for 56. So students, my function control is get back to the parent node, that is 45. That is 45. So here it is. Fine. Now if you can see here only 2 steps are completed for 45. So I need to complete one more, that is step number 3. That becomes true because 45 has a right subchild. That means we have 23. So we need to apply the function call for 23. So here it is the block for function call 23. So step number 1, just write down the data. So I'm just visiting the 23 and already get the answer for in the answer bucket. Okay. Then apply for the left. Do we have any left? No. Do we have any right? No. All 3 steps completed for 23. So students, the function calling is get back to its parent node, that is 45. Okay. So here my function calling is get back to the 45. So see this block for 45. All 3 steps are completed. So function call is finished. Function call is finished. So again it get back to its parent node, that is 85. That is 85. So here it is. All steps completed for 45. It get back to the 85. Now check 85. Step number 1 finish, 2 finish, 3 finish. That means function calling is finished. So it's just getting to popped out from the stack and all steps are done for 85. So here it is. Your recursion or preorder algorithm is completed over here for node 85. So your answer is 85, 78, 65, 45, 58 and 23. So this is how you can perform the preorder algorithm on your tree. Okay. Now let's move forward to the next algorithms. So students, here we have the next recursive in-order traversal algorithm. If you can understand the recursive pre-order traversal algorithm, then it is very much easy to understand about the in-order, because students, in in-order we have traversal like this. It is from left, visit and right. Okay. So first you need to go towards the left side, then visit the node and then move towards the right side. Okay. So just remember the steps for the pre-order algorithm and you can write down here very much easily. So students, in order, first the algorithm name is procedure are in order for T. You already know that what do we mean by the T. T is a pointer which is pointing to the root node first. Then we have the first check whether the tree is empty or not. See, if you want to traverse in tree, first you need to check whether the tree is empty or not. So how can you check that? If my T pointer is null, pointing to null, that means students, tree is empty. Tree is empty. So you cannot do anything. So just return from that step. That is step number 1. Now step number 2, we have that process the left node. See, just go with the sequence same as L, V and R. L, V and R. Okay. So first you need to visit left. So how to do that? First check whether the left node is exist or not. Condition for it, if LPTR of T is not equal to null, if LPTR of t is not equal to null, then you need to apply function calling over there. So your function name is Inorder. So here, if LPTR is not equal to null, then call Inorder of t. Okay, Inorder of t. No, wait, it's Inorder of LPTR of t. Fine. Okay, now next we have step number 3, where we need to move towards the write the data. That means visit the root node. That means just write the data of the root node. So what to do in that? Nothing, just write data of t. Okay. Now step number 4, that means move towards the right side. Before going to the right side, I need to check whether my right child is exist or not. For that, my condition is if RPTR of t is not equal to null, then call the function Inorder for RPTR of t. Okay, so it is same as previous, only the steps are just sequence is different. Here in Inorder, you first need to check about whether my trees exist or not. Then move towards the left side. Okay, move towards the left side. Then visit the data and then right side. Okay, so let's move further for the next algorithm that we have, recursive post-order algorithm. In post-order, students, we perform the traversal operations according to L, R and V. First move towards the left, then right, and then visit the node. So here first we have, first check whether the tree is empty or not. Same condition as previous. If t is equal to null, then you can write my tree is empty. Then step number 2, students, we have process the left node. It means if LPTR of t is not equal to null, then just call R post order for LPTR of t. Okay, and then move towards the next step. Students, next we need to call RPTR of t. Okay, so here we have for the right pointer, first check the right node exists or not. If RPTR of t is not equal to null, then call R post order RPTR of t. Last step, students, we have write down the data of the root node. That means just write data of t. That's it for post-order traversal algorithms. See, I'm not going to show the tracing for post-order and in-order. Okay, that you need to do at home because I have already shown it for pre-order traversal algorithms. Okay, so just take any example of tree and try to implement these recursive algorithms in order, post-order and pre-order on that particular tree. Okay, so that's it for today's lecture, students. Thank you so much.